Hello everyone, welcome back to On the Ledger. This is your host Mol Sayed, and I'm back once again on your weekly rendezvous from Paris. I wouldn't be the first to tell you that our lives are more digital than ever. I mean, you're probably listening to this on your favorite streaming service, while sending emails on your phone, or scrolling on Twitter. The point is, whether it be for work, communication, or entertainment, the digital portion of our lives is just getting bigger and bigger. And obviously, this digital transition generates data, a lot of it. In 2021, the internet consumed 79 zettabytes of data. That's kind of the equivalent of 79 billion laptops with 1 terabytes of storage each. And the thing is, despite this data being ours, we actually don't truly own it. Internet companies do. They absorb it and sell it back to us in the form of advertising, which is obviously quite profitable. Blockchain and decentralized storage technologies offer an alternative to that system. One in which you and I can truly own and monetize our data without the need for a middleman. One such project that's pushing the boundaries of the space is called Filecoin, and it's a decentralized storage network designed to store humanity's most important information. And the good news is that we've just integrated it with Ledger. But what exactly is Filecoin? Why is it useful? And how is it any different from, say, Ethereum or other blockchains? Well, we've got the right people on here today to provide us with all of these answers. First, we have Jonathan Victor, who's the ecosystem lead for NFTs and gaming for Protocol Labs. We'll be joined by Roman Beyon. Roman is Ledger's blockchain product manager, and he's part of the amazing team that has made this integration possible. Gentlemen, welcome to the show. How's it going?
Hello, Mo. Hey, nice to be here. Thank you for having us today. Glad to be here.
Great to have you both. So let me kick off this conversation by, first of all, asking you, John, the first question. What's the link actually between Protocol Labs and Filecoin so that people can understand?
Yeah, we get this question quite a lot. So Protocol Labs, we were founded in around 2014. Our founder, Juan Benet, he wrote the first implementation of IPFS. That was like the first precursor to Filecoin. Filecoin, he wrote the white paper along with Nicola Greco and some other folks in 2017. And Filecoin, you can think of it like an incentive layer that sits on top of IPFS. One important, crucial bit about how Filecoin works, Filecoin is built on top of IPFS, but IPFS doesn't require using Filecoin, and we can talk about how these things intersect. But Protocol Labs is like a large player in both of these ecosystems, where we maintain one of the implementations of Filecoin called Lotus. We build a lot of other auxiliary tools in the ecosystem. We work a lot with other folks to just try to grow the adoption of IPFS, Filecoin, and sort of the stack of tools altogether.
That's quite fascinating. And Roman, maybe you could tell us a little bit more about what it means to be a blockchain product manager at Ledger.
Sure, of course. So basically being a blockchain product manager at Ledger, my role is to help external developers, foundation like the Filecoin Foundation, to build on top of a product, meaning to integrate their own blockchain through synchronization, receive, send, but also staking and potentially NFT into the Ledger Live app. So our goal with my development team and QA team has been to, follow the process of the integration and making sure it's as easy as possible and as efficient and as transparent as possible when it comes to build great product on Ledger Live.
That makes a lot of sense. Thanks to both of you. And let's continue setting the table here so that people understand what is it exactly that we're talking about. Blockchains, are considered to be an innovation to the internet. So people might be asking themselves, why do we even need separate decentralized storage systems? Why can't everything simply be stored on the blockchain itself?
Yeah, that's a great question. So I guess people will have different opinions here, but I can give my take. So when we think about what are the properties that matter for a blockchain, I think it's interesting because people might disagree about what do blockchains actually enable. My take is that the property that blockchains sort of give us is verifiability. So when you think about why do Bitcoin folks care so much about people running their own nodes, or why does Ethereum target the block sizes that it does? A lot of that is about accessibility, where what we want to make it possible to do is that anyone can verify that the blockchain is progressing the way that it's supposed to progress. No one's changing the rules, no one's censoring, things like that. This is why we target small blocks and why we want people to run their own nodes and their own infrastructure. I think a fair question, and this is sort of the question that's more recently been posed, is, well, how decentralized do things need to be? Maybe we can have slightly larger blocks, and then it may mean that the requirements to run a node are slightly higher, but if we can still have thousands of people storing the full ledger, this is maybe more like the Solana bet, then it's still decentralized enough, and you still get these censorship resistance properties, you still get all of these other things that we sort of want out of the verifiability of blockchains. Well, if you take it way further and you think about okay, we're talking about the internet and it consumes zettabytes of data. We're no longer in a realm where it's possible to say, okay, everyone's going to have their own local copy of the internet. So now we have to start thinking about, so how can we mix the properties of blockchains along with the scale of data that we will need in order to actually bring all of this infrastructure into a system that's managed by a blockchain. So you still get the trustlessness, the verifiability, without having to store everything directly on chain. And so this is where Filecoin took a pretty unique approach. I apologize because I know we wanted to start a little bit non-technical, but this is where
that's okay.
Filecoin's big innovation is using basically cryptography and economic incentives to say, hey, there's a bunch of stuff happening off chain, but we can use zero knowledge proofs in this really creative way to verify what actions are happening off chain. So Filecoin itself, the blockchain, is something that you or I or anyone else can run on a normal laptop. You can verify the chain, and that chain is verifying statements coming from data centers and storage providers around the world, all of whom are committing storage capacity into the network, all of whom are storing users' data. And without revealing any information about the data or anything like that, they're still proving to the network, all of us who are validating with our nodes, that this is actually happening, that they're storing the data's still intact, no one's lost anything. This is the core twist, where by doing this, we can have a blockchain which still retains all of these properties that we care about for decentralization, making sure that people can verify all of that. But the storage capacity of the network can scale to internet levels. So today, Filecoin is at about, I think, 17 ettabytes of storage capacity. That's 170 cerns. The network is on track to double about every year or so. And so just thinking about what we're talking about, if every year we double, in 5 years, Amazon will be about the same, the total size of AWS will be equivalent to the size of Filecoin. A year later, hopefully Filecoin will be 2x the size of AWS, and you keep going, and you can see how this sort of expands out. But yeah, the thing with blockchains and why do we need these different systems? Well, if we actually want to support the full entirety of the internet, it really comes down to what are the possible ways of scaling this without sacrificing the properties that we care about for credible neutrality, verifiability, and all of that.
Mm-hmm. That makes a lot of sense. So what you're saying here is that the limited storage capacity of the blockchain is actually not a bug. It's a feature that enables people to actually run their full nodes and participate in making the blockchain secure, because the more decentralized it is and the more nodes out there are, the better the security of the network is. However, what Filecoin is doing is enabling data storage to be scalable, but at the same time secured by the network. And this is the link between IPFS. Maybe you could elaborate more on what IPFS is and how Filecoin is building on top of IPFS.
Yeah. So IPFS is pretty broad. The way to think about it is IPFS really has two interesting questions that it's trying to answer. One is, how do we change how the internet talks about data? If we were to use an analogy, when you go to google.com or any website really, you're going to http google.com, that URL is going to translate into someone's IP address. And that IP address is literally an address. It's bouncing you to a machine and saying please take me to whatever's here. And on your URL, there's usually that I don't know, it could be google.com/drive/whatever. That's a path into that computer saying okay, if you go all the way down here, the file that I'm looking for is at this location. Now, that works pretty well. However, it leads to some specific problems. One, it now has this reliance on the data has to live at that one specific location. So if, let's say, I don't know, Google decides that they no longer want to host this data, well, now you're out of luck. Like that was the URL, so you have to find a new URL that can reference the same piece of data. The other thing that it doesn't really give you is any verifiability about what the thing is that you're actually looking for. Maybe you go to that location and there's something else there that wasn't the thing that you were expecting. Because your URL isn't actually about the data, it's just saying where to go, you have no idea if like this is a virus, maybe like the website has been taken over by someone malicious, maybe it's data that like isn't the thing that you thought it was going to be, it's something new. And there's no way for you, or more importantly, your computer to really tell. So like the big twist with IPFS is, well, what if we didn't use URLs in the way that we've traditionally used them? So instead of talking about specific locations, what if we could have the URL just say like, this is the data I'm looking for? So like, what if we could use like a fingerprint of the data as the canonical reference? So like a good analogy might be if we were talking about a book like To Kill a Mockingbird, and you guys were interested in reading it, in the normal internet way, I might tell you like, come to New York, in the middle of town is a library and like 3 bookshelves in, 2 books on the right. That's the book that you're looking for. Now, of course, like your flight from like France, that could be blocked. Like maybe, I don't know, library burns down, book somehow disappears. Like there's many things that could go wrong and you would have no idea and no way of actually getting the book without being able to physically go to that one location. But if we were to twist this slightly and say, well, To Kill a Mockingbird, it was written by Harper Lee. It's got this ISBN number, this number of pages. You could ask me for the book. You could ask Roman for the book. You could ask anyone for the book. And whoever has a copy can serve it back to you. And you can verify it's the thing you were actually looking for because it meets the specific description that you had. So this is literally the core of IPFS, which is just change how the internet talks about data. So instead of talking about where content lives, we just talk about what the content is.
Because the content actually lives everywhere. That's kind of the
exactly.
idea.
Data is not a property of where it lives. It's just data. And then we solve the things about like, how do we make sure someone has that data? That's where something like Filecoin comes in. Or like, how do we solve other properties about like moving the data, things like that. But we can solve these as separate layers. And so when I think about IPFS, it's actually a super broad protocol and it's used by a number of different folks. So it's not just Filecoin that uses IPFS. There's other storage networks like Crust that also use IPFS. There's other compute networks, so like Fluence, which is like a compute over data protocol. Ceramic, who's also doing a bunch of really interesting stuff with compute over data and like identity. Like a lot of these folks, Celestia, which is like this new data availability protocol in Cosmos, everyone's sharing the same canonical language about like, how do we talk about data? And then you can solve all of these other services out of band. So that's sort of like the IPFS side of the house. And then the way to think about like Filecoin, and I would argue this is how to think about blockchains in general, things like Filecoin offer open services where if IPFS today just says like, hey, I can reference data, but I'm leaving it as an exercise to the reader to make sure that that data is persistent, to make sure that that data is delivered quickly, that I can do stuff to that data. Like those are services that you could go to a centralized provider for. Like you could run an IPFS node in AWS, but you could also go to these permissionless protocols where you can say, hey, I can use a smart contract to say, please, Filecoin network, make sure there's always 5 copies of this data on the network for me. And then I don't have to trust any individual person to do a thing. I can use the blockchain and the verifiability of saying like, I see these proofs coming in to always know that I have however many copies of my data persisted, available, all of that through the network.
Mm-hmm. There are so many follow-up questions that I have, but I think one that I would like to double click on is the difference between IPFS and Filecoin, that Filecoin has its own economy. There's the fill token, and there's kind of an incentive to, store this data. Could you maybe elaborate a little bit more on that and what Filecoin actually has in terms of benefits when compared to IPFS on its own?
Yeah, so I would say Filecoin today has one set of benefits, and then I think there's some really exciting things that are coming up on the roadmap that will continually add more and more. So today, if you're using Filecoin does basically one thing, and it does this one thing with some very specific properties. Filecoin stores your data. So like you as a client, you can make as many deals as you want with different storage providers around the world. I think there's something like 4,000 plus of these like data centers, people who are just advertising that they have storage capacity. And the network is enforcing a minimum amount of quality from that storage service that you're procuring. For the storage provider, they have to lock up some collateral on the network. And then they're required by the protocol to prove to the network that they're still in possession of this data every, I think it's 24 hours. It might be slightly under that, but every 24 hours, every sector. So like literally all 18 ebibytes of storage capacity is like poked to see like, hey, is this actually still online? And you have a proof coming in that shows that this is happening. And so the proof can't be falsified. This is again is like the zero knowledge part of stuff, but like unless you have, there's like a probabilistic guarantee, but it's like very, very like long tail stuff. But yeah, you use the proof as the mechanism to say like, the only way you could have generated this is by doing the correct action. And if you don't want to lose money, like the blockchain itself is enforcing to say like, I will slash you and take away your collateral unless you can submit to me this proof on this cadence effectively.
So it's similar to proof of stake, but the stake you have here is the stake that you're guaranteeing the fact that you will be protecting these documents and making them available to whoever paid for it. That's
exactly.
That's the idea.
And I think, and so the verifiability, I think, is like maybe the unique new feature that you get with these proofs. But I think as more and more features roll out, you can start doing more interesting things with that basic primitive. I should also note the other thing that Filecoin does is because Filecoin's storage mechanism is also its consensus mechanism, it's actually quite advantageous for users of the network because you have this additional subsidy to the cost of storage, which is literally by performing the act of storage, miners are getting two forms of compensation. There's like potential fees a client might pay, but there's also the block rewards, which the network is paying them for providing security to the network. And so you have this really large subsidy that actually makes the cost of storage incredibly cheap. But when we think about like what do these services have and where are things going, I think it gets much more powerful. So later in like February of next year, Filecoin is launching smart contracts. And so you can start squinting at this and seeing like, so what could you do with these different primitives if you were to combine them with other things? So like today, if what I can do is I can make a deal and say like, I'm storing my data with Roman and he's going to prove to the network that he still has this data over time. Well, I could write a smart contract that sits on top that says, hey, I'm going to put a bunch of money into the smart contract. And I'm going to say, every time like Roman fails to perform a proof, I'm going to set up an auction and automatically bid out and say, anyone who wants to store my data, you can now store a new copy and I will pay you. And so you can create these incentive systems to string these deals together, to just have them go on in perpetuity as long as you'd like. That bucket of funds can look a lot like an endowment or a pension fund, where it's like, take this capital, put it to work. And so when we start thinking even about, when we think about like DeFi, a lot of times if you talk to like traditional financial media folks, they're just like, okay, DeFi is really cool, but is it turtles all the way down? Like who needs crypto economic rails? Like who is paying for this stuff? And a lot of times it can look like, oh, well, there's these large institutions that are trading, so that's like one set, but then you also sort of have like the PvP, like people just sort of like flipping tokens back and forth. I would argue one of the reasons that there's a bit of a gap here is we haven't had more businesses that have formed that need truly crypto native rails. But one of the interesting and kind of exciting parts about having these open services, like Filecoin has 4,000 businesses that are tied to our economic rails. All of these storage providers are businesses that have revenue streams denominated in Filecoin. So like, what do they need? They need a bunch of financial services. They need to hedge their OpEx. They need to be able to like get like loans from folks. And you can use the primitives of the blockchain to be able to do things like under collateralized lending, because you have a revenue stream that you can like write a smart contract to garnish the wages from if you offer them a loan. So I think we're like at the early innings, and I would argue DAOs are maybe the other side of this where it gets really exciting, where like as we see more and more businesses that are like truly like embedded into crypto rails, I think it starts answering the question much more cleanly of like, what is even DeFi for? Where it's not just like, oh, we're waiting for the institutions in the traditional world to adopt crypto rails. It's like, we can build businesses too that natively integrate with these rails that become their own consumers of these services.
That's mind-blowing. Seems like this is just the tip of the iceberg. But, you know, this is all centered around the fill token. And Roman, you know, Ledger's often asked when X token. This is the questions that we always get. When do we integrate this? When do we integrate that? And I think Filecoin was probably one of the most frequently asked questions. So for people to understand why it's not done in a minute, maybe you could explain what it takes for Ledger to effectively roll out an integration at such scale.
Sure. And Mo, you're totally right. The when coin type of tweet is definitely becoming a meme in Ledger Twitter community. And the when Filecoin was most probably one of the most repeated one. That's for sure. So now, if we want our listeners to understand how Ledger is able to follow up with all the new protocols and integrate them into Ledger Live, I think we need first to have a look in the past and analyze which wallet strategy we put in place. So in 2016, the crypto ecosystem was mostly Bitcoin, Ethereum, and a few noticeable forks. Then something happens, which drastically changes the crypto industry. The ICO craze of 2017. So it triggered a true innovation wave for the good and for the worst, and the number of crypto projects just skyrocketed. And if I remember correctly, it was at that time that Filecoin did its ICO, rating more than 250 million USD, making Filecoin one of the most anticipated and successful ICO. Clearly, this period was amazing for Ledger, but with only a few engineers to work on blockchain integration, the pace was impossible to keep up with, and we needed to find a solution to achieve our multi-asset wallet strategy, which is basically to always support top 50 coin on Ledger Live for users. So this is at that time that we made one of the biggest strategic move, which was to build the Ledger platform. So for the listeners who are maybe not familiar with the concept of platform, think of the Ledger platform like Apple iOS, Google Android, or Microsoft Windows, which allow external developers to build new use cases on top of them, making the platform even more valuable to users. So long story short, we decided to open our product to any crypto foundations, developers, or projects willing to integrate the blockchain or app on Ledger. And now you can build on Ledger the same way the Filecoin Foundation worked on integrating its blockchain on Ledger Live. And the cherry on the cake is that you will benefit from the end-to-end support from the Ledger team all along the process. So basically, if you want to follow the Filecoin example, the only thing you need to do as a developer or as a project leader is to reach out to us on our dedicated Discord channel, Ledger Open. And Mo, if you could provide the link to our Discord in the description would be amazing. So to recap, how we are rolling out blockchain support at scale by opening Ledger Live to external contributions through this platform strategy and making it possible to have amazing projects like Filecoin, but also Cardano, Elrond, Crypto.com, and more, building their own integration on top of Ledger products.
Yeah, that's a great explanation. Thanks, Ramon. And I think to move over to like another topic, I really want to put myself in the listener's shoes. Imagine I'm an NFT artist or a collector's DAO, and I want to protect and store the assets, whether it be the images, the files that are connected to my NFTs on Filecoin. How do I do that?
Yeah, there's a couple different ways. So Filecoin itself is like a pretty low level protocol. And so typically it's not like a Dropbox thing where you drag and drop files and it just goes there. So typically people are using one of these like on-ramp services or they're running their own infrastructure. And so I would say the easiest, which is like, I think for folks who are they want to just throw stuff into the network, is to use something like nft.storage. That's literally the website is nft.storage. And that service basically has a bunch of public IPFS nodes where you upload your content. It makes the data available over IPFS. You can there's a gateway that's indexed to NFTs too. So you can do all the good stuff for retrieval, all of that. But it runs this pipeline in the background where it just batches up all the data and stores it all over the Filecoin network. And there's actually even like a little API. So there's like literally a query that you can run that just says like, tell me where this CID is, like who has my data? And then you see like, here's the list of miners that have the data. And you can go verify that against the Filecoin blockchain to say like, is this actually happening? Can I actually see it?
And how much does it cost if you go to nft.storage? Is that the website?
Oh yeah, so NFT storage is actually totally free. It's like a public good in our ecosystem. Storage on Filecoin, I guess to put this in perspective, it's like scientific notation per terabyte per year to store data on the network. It's like bananas cheap. The project itself for NFT storage, you can think of it a little bit more on the vein of like other public good funding projects. But yeah, like later when the FVM launches, it's turning into a DAO. It's going to be seeded with a bunch of money. But that's like just one way that you can do it. There's other services where if you want to directly like run it yourself, so like estuary.tech, that's one that will also, it's a node that you can run yourself, but it will automate the process of making deals, all of that good stuff. You can top up a little bit of Filecoin in your wallet and just have it go. There's other services as well. ChainSafe has some, Fleek. There's like a whole list of providers, which yeah, we can share. Yeah,
That's pretty interesting. How easy is it for a newbie to actually, manage to store their files using some of these services that you've just mentioned?
I think so if you were doing it yourself, there's more like work involved. I would say that tends to be a little bit more complicated. I would say Estuary, if you're running it yourself, reduces a lot of that complexity. There's still some overhead, but I don't know, it shouldn't be. If you've run an IPFS node, it's about the same complexity there. And then I would say the simplest, where it's like if you've never even run an IPFS node, is something like NFT storage, Web3 storage, ChainSafe files. These are just like, they will feel very intuitive if you're just like someone who's used JavaScript. Like they have libraries, you just like send data to the service and it will batch and store. And so then it gives you like the full spectrum of like how mountain man do you want to be? Do you want to do everything yourself? Cool. There's like a bunch of work involved to do that, and that's fine. But there's also like, hey, I'm just a developer, and like what I want is my data to not be locked into one service. So if like I want to port off your service, I'm not stuck here, and it's not like there's something that's blocking me from migrating from A to B. And that's how like a lot of the like further end services sort of operate, where they're like everything is just data. Here's where it is. It's outside of us. Like we're offering you a value add service just by making it easy to do. But yeah, no lock in, none of that stuff.
Makes a lot of sense. And I guess the intuitive question here would be, how does the protocol kind of guarantee the authenticity, also the security and verifiability of the files, despite them being dispatched across multiple locations? If one of them maybe gets hacked, or what would happen here in terms of like the security of the initial files?
Yeah, so there's two proofs in the Filecoin ecosystem. There's proof of replication, and then there's proof of spacetime. So proof of replication is the first thing that happens when you send data to a miner. Basically, the miner has to prove to the network that they are actually storing your data. Part of that process, it uses a data structure called a stack DRG, but it basically does a lot of fancy stuff to basically say, it is actually impossible for you to like perform this proof properly. So proof of replication, there's like multiple components to it, but effectively it's like, how do I know for sure that you are storing a unique copy of this piece of data? So like the other type of thing that you want to make sure is not that like, if I give you a copy of my data and say, please store 5 copies, or I give it to 5 different miners that happen to be controlled by the same person, what I don't want is for that person to store only 1 copy, but tell me that they've stored 5. And so proof of replication allows you to say, hey, I've given you data and this person is storing a unique version of that data. And so proof of replication is like, how do I make sure the right thing is being stored? Proof of spacetime is, how do I make sure that this stuff has been stored over time? And so literally the miners are challenged by the network to say like, okay, you have to now like show me a proof for this. And then they have to like prove that they still have this data. It's actually like sampling a bunch inside of that sector. But then that little zero knowledge proof is what's posted back on the Filecoin network. And then that gets verified to say like, if this hasn't been done properly, the miner will get slashed and lose collateral. So like, that's how you sort of like close the loop. So the first half is, did the right thing get stored? And then the second half is that thing still stored properly? And so to your question, if someone tries to tamper with the file, well, one, if it's the miner, they will lose a bunch of money because they won't be able to do the proofs that they're supposed to. On the proof of replication, they wouldn't be able to store the wrong file because the deal wouldn't start unless like this is again, like you as a client in your proposal, you submit a thing and they have to match it. And the only way they can do that is by performing the proof of replication properly. It's called a COMP. But effectively, yeah. So you sort of like try to use the cryptographic side to verify that the right things are happening. And then you can think of the blockchain more as like a settlement layer, where it's like the miner is claiming that they are storing my data. I can now verify that on the chain and use that to enforce this economic like penalty incentive system.
Makes a lot of sense. So what you're saying here is that the miners don't even have access to the files because they're encrypted, and that if they ever try to tamper with the files, then they get slashed, and the rest of the network would actually be proving that there's one miner that is actually tampering with the files that they have, because all the files that they hold haven't been tampered with. So when compared to the initial file that was tampered with, they will all seem to be the file that was tampered with will seem to be different than the others. Is that
Exactly.
correct?
So one little tweak to that is that Filecoin itself does not enforce encryption. So like part of the reason for this is some data you don't want to make encrypted, like NFT data, mostly public. And so if you have public data, if you force encryption, you now have introduced a new problem, which is like, okay, how do I make this broadly viewable by everyone? So it doesn't encrypt by default, but it gives you those properties to say, yeah, I know that this is the right version of this data. And I can prove that the person has, like, if they do tamper with this, then they will not be able to produce the proof that shows that they have the thing they were originally given. So they have no incentive to. And in fact, they have a strong economic incentive to not do that because they have locked up all this collateral that they will lose if they can't do it properly.
Makes absolute sense. So switching gears here, Roman, one now can send and receive fill from within the security of their ledger device. Can you explain what's the benefit for the user to do that versus using an exchange, for instance?
Sure, of course. So first of all, this is a great question, and this is the type of question we should ask in this type of podcast with Ledger. So Mo, I will answer your question just with one statement that we care a lot at Ledger, and probably John, you will agree with us, and you know this statement, which is not your keys, not your coin. Basically, let me elaborate on this for all listeners. Basically, when storing your coins on an exchange like Coinbase or Binance, you're basically giving the property of your assets to an external entity, meaning you're not in control anymore of your assets. So when your crypto are held on an exchange, there is always a possibility that your crypto can be unilaterally seized, confiscated, or the exchange could even be hacked. And to illustrate my point, in 2021, more than 4 billion worth of crypto were hacked from exchanges. Moreover, we recently observed with the Celsius drama that users could also lose their life savings if the company were to go bankrupt. So all of this to say that if you need to use an exchange or any custodian platform, do it, but with this consideration in mind, because this happens all the time. Now, how does Ledger differs from an exchange, and what is our value proposition? At Ledger, it's the same as Filecoin, the same as John here, I guess. We strongly believe in financial sovereignty and individual freedom. We believe that people must have full ownership over their assets. When using a Ledger device in combination with Ledger Live software, users are in control of the keys and can manage, send, receive, grow, but also buy, sell, and swap their assets from the safety of their hardware wallet. So, to sum up, exchanges equal you transfer ownership of your keys to an external entity at your own risk. Ledger equal you stay in control of your assets while accessing a variety of services from stake to buy, sell, and swap. So for Filecoin users, you can now manage your Fill token on Ledger Live. You will soon be able to buy and sell Fill directly from Ledger Live. And we strongly hope that the next collaboration between Filecoin and Ledger will be maybe staking integration, for example.
Yeah, well, one thing also to call out is when you have your assets on like your own wallet, things that you control, you can actually do stuff with them. And I think like this is, I think, where if you had all of your assets sitting on an exchange, you wouldn't have been able to buy an NFT or participate in DeFi. And as all of these new applications are being built out, like it does require being able to like actually be in control of your own assets. And so, I mean, even from the like, maybe people don't buy the like, oh, like whatever security side of it. It's also just like from a pure utility side. Like if you actually want to be able to participate in the crypto economy, like you need to have your assets in your control. So yeah, another consideration for your listeners.
But I mean, it's pretty straightforward. It's just a matter that, you know, when you think about it, we've all been used to using third-party services, and now we're moving away from that paradigm. And self-custody has a lot of benefits, but we always say that with big freedom comes big responsibility. And education about how to manage your keys, how to safely navigate the space, what to sign, what not to sign, what to look out for is definitely needed. And this is definitely what most of the projects in the space are trying to put forward. Let's speak a little bit about the future. And Jonathan, we touched on that at the beginning of the conversation. Obviously, the internet consumes a lot of data. We said it was around 79 billion laptops with 1 terabyte storage capacity each. And you've touched on that a little bit, but how long do you think it'll take Filecoin to be able to absorb that amount of data?
Ooh, that's a good question.
And what's the process that'll take us through the process? The step-by-step process and how long it'll take us.
So there's like two sides of this. There's sort of like, how do you get that much capacity? So like, how do you add that much hardware into the Filecoin economy? And then the second is like, how do I actually move data of that scale onto these systems? And I think all of these things, you can look at it sort of like, what is the friction involved and how do you remove that friction to basically zero? I think on the hardware side, so for like all these Filecoin storage providers, today the mining process is a highly coupled one. You have to do multiple jobs at once, but there's work going on that's turning that into a much more modular process. And so as that happens, you'll probably see specialization, but it also means that you'll probably see a massive ramp in that specialization, the cost of doing all of these things gets cheaper and cheaper. You'll see a lot more like folks who just specialize in one type of storage as an example. And then like those types of organizations will kind of grow. I think coupled with that is things like DeFi. I actually think one of the other big rate limiter for a lot of storage providers is just access to capital. We were talking about staking. The moment people build some of these protocols, and there's a number of teams working on this, but getting super cheap access to capital to miners, allowing like folks who are token holders to put their like tokens to work and like work with and like the storage providers to like grow the ecosystem.
Sorry, just to not to interrupt you, but there's an interesting thing that I'm thinking about is that now that Ethereum is moving to proof of stake, maybe most of the miners would that actually help with the miners that are actually participating in the Ethereum network, maybe looking for other opportunities for them to leverage on their hardware and GPUs, to your point?
Yeah, I mean, so there's some amount of it. So as the process for mining gets a little bit more modular, there's one part that is pretty GPU intensive that could be like a good candidate for Ethereum miners who are looking basically to repurpose their hardware. I think maybe more importantly, though, is when we think about Filecoin, it's not just storage. Storage is like part one of like the master plan. It's like storage, retrieval as like a separate set of like nodes that are doing their own permissionless CDNs. That's like part two. Compute over data. So like literally, how do I send out in the same way that you might use EC2 and Amazon? What I actually want to be able to do with these petabytes, exabytes of data is say like someone run this filter or this transformation on this data set or run a machine learning algorithm on top of it, right? All of those require different types of compute infrastructure, but like those are three different services. And especially that last one, the compute infrastructure, is where I think probably for a lot of these like soon to be homeless Ethereum GPUs, there might be a really compelling answer for what do you do with that stuff? Build out compute networks. But for Filecoin, it's like these are three open services that we sort of know should be anchored in the same economy. It's all services around data. And then you can tie that together with smart contracts and like there's this whole thing about hierarchical consensus. But effectively, like think about the blockchain itself as like this economy. What we're building is an economy for data. Smart contracts give you more expressivity around like how do I define what do I want to do with data? What can I like trigger in terms of payment? Like what other services are anchored into the network? But really we're just talking about what are all the different ways people can like do stuff with their data on this network. And so I think that's like actually we're still in like I jokingly call it the Roadster era of a Filecoin, or like the first Tesla Roadster. I don't know how much people follow Tesla. I used to be very big into Tesla. But the first Tesla Roadster, the point was not that it was like the best car. The point was that it was an electric car that was fun to drive, had terrible range, it was expensive to manufacture, they had to do it by hand, weird chassis. But if you look at the Roadster to the Model 3, what happened? Well, you have 10% improvement to the drivetrain, the battery chemistry, heat exchanger, aerodynamics, and you stack up all these 10% improvements and you get a 100% better car with better margins to manufacture at scale. And I think this is actually the big bet where it's like, okay, today we have this mining process. We're able to acquire massive amounts of hardware. Every proof upgrade that we ship hits 18 ebibytes of storage capacity. Like we can upgrade the entire fleet of the Filecoin storage network collectively. As these things that come that reduce the cost of onboarding, you'll see a massive ramp in the onboarding. Things like DeFi that make capital more accessible for these storage providers, another accelerate to like the growth of the network. And so you can sort of see like how do these flywheels kick off together, where it's like, what are the different things that you have to unlock if you want to really reduce that friction? So that's how do we get to the stage where we can have enough capacity to truly hit internet scale? I think this is like the seeds that you sort of have to have if you want to eventually get to like the full exponential. Now, the second part of the problem is not just hardware acquisition. It's like, how do I get all that data onto this network? And like, funnily enough, this is actually more of a physics problem than it is like anything else. When you have data, like when we are like talking over Wi-Fi, right? Like we're using radio signals and like my Wi-Fi router is connected through fiber and that's like bouncing around. But like there is a limit to how much information I can push through the wire, which is like just send over the internet. And so the two ways that you can sort of do this is either build more native applications that just start on crypto, like managed by the network, that are distributed through the network, things like that, or figure out how you can actually do the thing that any big data migration uses, which is like physical shipments. So like literally moving tons of data sets into the Filecoin economy and then being able to transfer and do all these other services on top. And so there's teams that are actually doing this. So a good example, the USC Shoah Foundation, they have, I think it's something like 9 petabytes of like basically like testimony about genocide. So it's like video evidence. A large part of what they do is just proving that this is authentic video that was captured that hasn't been tampered with. It's a very strong match for like what we do in the Filecoin economy / network. And yeah, I mean, when you're talking about that size of data, they're literally just sending hard drives to put this data onto the network. We can still use the cryptography to verify it is the right data. The correct actions have been taken. The Filecoin network is just the settlement layer for all of this stuff that's happening. But now you have this archive that's available over this network where if someone just needs a sliver of it, they can easily request it and just grab the subset they want to go work with. And you don't have to move the whole thing. So like, I think the punchline for how do we actually move the entire internet over, I think you got to pincer attack it. It's like both start with build more native services that are just generating data inside of the Filecoin economy. Hopefully those services will end up chewing up and like being dominant. If someone builds like the next, I guess Lens is the next social media thing, but the next social media thing that's directly writing their data into this infrastructure, it doesn't require then like a migration of anything. It's just, it'll already be in there. The other half of it would be, for things that already exist. So all the billions of hours of YouTube videos that are up there, like making it possible for people to move their data into these networks and having seamless pipelines that make that possible as well. Things like compute as well.
Yeah, makes a lot of sense. And this element of data transferability and interoperability and being able to offer a very seamless way for people to transfer that data onto the network, I think will be a huge unlock. That's actually a question to both of you. When you think about the future of the space, what are you most excited about?
So I think the most exciting thing in the last few years has been like DeFi followed by NFTs. And I think the thing that I am personally most excited about is seeing these primitives not just be seen as like, this is stuff that's happening inside of crypto. And it's like I think a lot of the reason that we have these kind of heated conversations with the outside world is people are like, okay, you've built these really interesting, complicated toys, but like, what is the point of all of this stuff? And I do think being able, even for NFTs, like I think a really concrete example of like an NFT that would be productive is just like a corporate bond as an NFT. Like what is a ratings agency other than like assigning specific properties to a corporate bond? But you could take a lot of these tools that you have for like fractionalization is like, who deserves the dividend? Like you can sort of squint at this stuff and see how you might use the primitives that we've built in crypto for other things. But like you could even extend it further. So like for DeFi, I see the interesting next step being like, how do we use like open services? So like Filecoin, how do you tie that with the financialization that DeFi has sort of like pioneered and like bring those two things together? So if I want a perpetual storage thing on Filecoin, it's literally just like pool of capital, automates like yield generation and then use that yield to fund ongoing services. That seems like I mean, direct parallel to like, what does a university do, right? Like a university will have an endowment, it will put that capital to work, and it will use that to fund ongoing services. So like, these aren't new ideas. It's just like the version that makes sense inside of the crypto realm. And I think like, as we bridge between those, I think more and more people will sort of see what I think a lot of us see, which is like, how does this stuff sort of take over? And like, even for NFTs, you could look at it as like, how do I have permissionless certifications? So a really cool project in Filecoin's ecosystem is this thing called Filecoin Green. It's literally a team that's using Filecoin's blockchain to estimate the energy consumption of nodes on the network. It's just like, what is the upper bound of the energy based on the messages that you're sending? And then they literally will do an audit and say, like, show us the local renewable energy certificates, the RECs, that show that you've sourced local like renewable energy. And so what they're doing with those audits is they're just basically making this public. So you can go poke at any node and say, like, show me if this person is sourcing renewable energy or not. Now, imagine if that was an NFT. It comes from the smart contract owned by the Filecoin Green team. You can choose to trust them or not trust them. But in the metadata of that NFT, it can have all of the background work that they did so that you can draw your own conclusion about whether you believe that they have done a valid audit or not. It's not like just trust us that we said that this thing is green or not. It's like, here's all the data, verify for yourself. But that NFT now can be an input to a DeFi protocol where it's like, maybe I want to have an ESG fund that only lends my capital to miners that are verifiably green. Now with this NFT, we have like the full lineage and the traceability of like, what are the claims someone's making? What is the input data? But you can tie that to the financing side and say like, hey, I, as an ESG fund, want to only support people who meet specific criteria. It could also be the case that you as a client, maybe you are an NFT artist and you only want to store your data with miners that are sourcing renewable energy. Like that becomes a primitive that you can also use as well. And so again, I think like the thing that gets me most excited is we've seen like the first versions of these things and we've seen them in like very specific contexts, but I don't think we've gotten to the stage yet where it's like, have we seen all of the practical implementations where we take these primitives and remix them in other ways? And that to me is like in the next 2-3 years, like where a lot of the excitement is going to be.
Yeah. Feels like we've seen them in silos, but we haven't really seen them to their full potential of, as you said, like getting mixed together and like combining different ecosystems that have very specific purposes. Roman, what's your take about that?
Just something I wanted to mention about the fact that all these technologies are working in silos right now. Like Filecoin is the perfect example that technologies that were existing in silos gathered at some point to create a great product. So if you think of gathering like ZK proof, which is a new type of cryptography that just emerged very recently, which is super new, blockchains and IPFS, which are also different technology, and you mix it all together with smart people and you have a great product, which is Filecoin. So it's super interesting to see like these waves of innovation in cryptography and protocols and everything. And, you know, some smart people at some point just find some ways to make them all together and to create a product. So it's actually quite cool to see. But, you know, my takes now on what I think is interesting. It's definitely a tough one, Mo. But I would say first that at Ledger we are kind of blockchain agnostic, meaning that we always listen to our user needs and market trends, and basically our goal is to integrate the top coins and dApps. But really, if me and my team we had to highlight two subjects that we strongly look at, I think this will be the following. So the first one, which is an implementation of the ZK proof, it's ZK rollups. So here, this might become very technical very fast, but I'll try to make it as easy as possible for listeners. So basically the problem that ZK rollups are trying to solve is blockchain scalability challenge, meaning increasing the throughput of the Ethereum blockchain. So zero knowledge rollups, aka ZK rollups, are layer 2 scaling solution that aim to increase throughput on Ethereum mainnet by moving the computation and the state storage off-chain. So it's quite interesting to see because there are many innovations in this ecosystem, and many layer 2 scaling solutions like, for example, Starknet, ZK Sync, they are emerging. And at Ledger, we are really watching this innovation closely, as it would allow our users at least to interact with decentralized exchanges, decentralized lending protocols, and other decentralized applications with cheap fees while still benefiting from the security of the main chain, which is, of course, Ethereum in this case. And the second thing that we are really looking at is privacy coin and kind of, let's say, the financial sovereignty subject. At Ledger, we are really recently observed very kind of concerning events when it comes to financial sovereignty and individual freedom. Like from the recent arrest of one of the Tornado Cash core developer just for writing line of codes, to the ban of like 38 addresses by Circle, which is the company issuing the USDC stablecoin. But also in Europe, but the new regulation compelling centralized exchanges to disclose all their users' information to the authorities. So, like even if at Ledger we absolutely do not support crypto usage for illegal purposes, we do believe that individual freedom and ability to transact value on the internet in a private manner is absolutely necessary for an healthy and, let's say, a sovereign society. This is why we are really closely looking into these innovations into privacy coins, and we will support them as much as we can. But just one quick note for the listeners: please know that this is not a financial advice, right? Thank you.
Yeah, I mean, focusing on all of these, I would say, user benefits and how to your point, John, like these incremental improvements will be able to provide better benefits than Web 2, because this is the comparison, right? Are you going to use Web 2 service, or you're going to use Web 3 technology? And it's about moving from the Roadster to the Model 3, and the more we're able to get closer to the Model 3 version, the better it will be. And I think having all of these amazing talents and projects collaborating together, and interoperability is huge, I would say, advantage, because it's a non-zero sum game. Web3 is a non-zero sum game, whereas when you compare it to other models, it might not be the same thing. But anyway, gentlemen, it was a great pleasure to chat with you today. I'm very, very much looking forward to how Ledger and Filecoin will continue building great products in the future and great services for both of their communities. And yeah, hope we'll speak again soon.
Thanks for having us.
Thank you, guys. Thank you, John, and thank you, Mo.
That's it for today. If you want to learn more about Filecoin and its Ledger integration, be sure to check out Ledger Academy. Decentralized storage is such a fascinating rabbit hole to fall down of. This was On the Ledger from Paris with your host Moul Sayed. Till next time, take care. Au revoir. This content is provided for informational purposes only and is the sole expression of our opinion, and should not be relied upon as legal, business, investment, or tax advice. Do your own research. Any loss or profit is your sole responsibility. Stay safe.